gardinero.
We have different properties of parent materials that influence the rate of weathering. One is texture, the other one is hardness and degree of concentration, and the third one is the chemical and structural characteristics. Texture can influence the depth of soil. If the texture of the parent material is fine, they will result to shallow soils, and if it is coarse textured, this will result to the formation of deep soil. So the photo below shows you a fine textured rock, and then the other one is the coarse textured rock. Fine textured rocks are generally resistant to weathering, while coarse textured rock easily weathers, so that the rate by which the rocks weather contributes to the development of soils. Hardness of the rock will influence the rate by which the rock weathers. Rocks that are not hard will be easily weathered and will result to the secondary minerals. But persistent rocks, or rocks that are persistent to weathering, will contribute to the sand fractions in our soil. Example is the dense quartz or the dense SiO2 or sandstone. They are resistant to mechanical or physical weathering. They are the chief constituent of sand fractions in our soil. Porous rocks, like the volcanic ash, are readily broken down into smaller particles. Thus, it is easily weathered. So on the photo is a dense rock, and then below the dense rock is a picture of a porous rock. So again, dense rock is persistent to weathering, while porous rock is the opposite. The third property that influence the rate of weathering is the chemical and structural characteristics. Generally, minerals that contains iron are easily weathered. So I'm showing you an equation on how minerals containing iron easily weathers. And this portion will be discussed further in the chemical characteristics of our soil. We have the general order of weathering of some of the common minerals. So quartz is the most persistent, and then muscovite, potassium feldspar, sodium or calcium feldspar, mica, biotite, hornblende, and augite, and then followed by olivine, followed by dolomite or calcite, and the list is gypsum. Gypsum is the first to weather. Other properties of parent materials that affect the rate of weathering is stratification. And the picture below shows you a stratified rocks. And the second factor of soil formation, which we will discuss, is the topography. As mentioned a while back, topography modifies the climate and the movement and accumulation of water. And on my slide, I am showing you a diagram of a mountain and the topography and the different parts of the mountain. So topmost is the summit, and then below the summit is the shoulder. We have the back slope and the portion by which sediments deposit is the foot slope. So in my table below is the comparison of steep and nearly level slope with regards to the movement of water, the runoff, the erosion, and the horizon. Okay. So we are comparing steep slopes versus the nearly level soils. So in steep slopes, drainage is faster, but in nearly level soils, it is slower. In steep slopes, runoff is greater, but in nearly level soils, runoff is slower. And in steep slopes, erosion is faster, but slower in nearly level soil. And the resulting horizon in steep slopes is shallower, but in the nearly level soil, as you can observe, it is deeper. So there is an opposite result with respect to the slopes. Okay, this is the diagram showing you the increasing runoff and erosion as affected by the slope. In my slide below, I'm showing you the difference of poorly drained soil profile and that of well-drained soil profile. In the poorly drained soil profile, the resulting soil is very shallow, while that of the well-drained soil has a thick profile. And you can observe also that the slope is steep in poorly drained soil profile, but in well-drained soil profile, it is a little bit smoother than that of the poorly drained soil profile. The resulting soil formation in the slopes can be influenced by the movement of water.
Il Gardinero